All right, so today what we're going to do for day 2 of applications is we are going to start by just using some of these other what we call reciprocal functions just to kind of start reviewing for our test later this week, um, and make sure that we're ready to go with what they mean, remember what reciprocals they work with, and then get some more practice doing real world angle of elevation depression problems, and then kind of a little more advanced style ones later on in this packet. So what we're going to be doing, all right, make sure that your page looks like this, all right, and make sure that you have your graphing calculator or some form of a calculator out for us to work with these. So we're going to start with number one. All right, now number one says find the secant of 45 or 54 degrees. So here's the thing though. All right, first off, on all of our calculators, we want to make sure we're in the correct mode. I'm not, I'm in radian mode. So make sure you go to degree mode. So again, I went mode right up here. I'm in degree mode now, second mode. Now I'm good to go. But I look and I only see sine, cosine, tangent. Where the heck is secant? Well, unfortunately, these are called reciprocal functions, and these are not on our calculator. So what we're going to have to do is we're going to have to remember what reciprocal function matches to secant. So if you remember before, there was a little saying, if it starts with C, all right, and matches with S, and it starts with S and matches with C. So what that means is cosine goes to secant, all right, and back and forth. And then sine goes with cosecant, all right, back and forth. And then cotangent, tangent, and that one's easy because it has a T. All right, those go together. So, all right, how does that help us out? Well, secant, I can't do secant of 54 in my calculator, but what I can do is I can say, well, secant is the same thing as saying 1 over cosine of 54 degrees. These are equal in value, all right, because they're reciprocals of one another, all right? So secant of 54 is equal to 1 over the 1 over the cosine of 54. They mean the same thing. So in our calculator, we're going to go 1 divided by the sine of 54. Excuse me, I did sine again. I don't know what I'm thinking. Cosine of 54. All right, hit enter, and that's what you get. You're going to get about, all right, 1.70. That's what that cosine would be. So what would cosecant of 88? Well, cosecant's not on our calculator, so this is a reciprocal of sine. So it's 1 over sine of 88. Those are equivalent. So we're going to go 1 divided by sine 88, and bam, you're going to get about, really, rounding to 2 decimal places is just 1. All right? So let's try one more. Cotangent of 140. So cotangent, all right, is really 1 over tangent of 140. So we put that in our calculator, 1 divided by the tangent of 140, and bam. Ooh, we're getting a negative value. Negative, what is it? 1.19. Now, you might be saying, wow, that kind of doesn't really make any sense. That doesn't do anything for me. Well, understand, all right, negative, these are lengths, all right? These are ratios of sides with lengths. So this one doesn't make any sense. That one's not a good one for us to work on. But again, all right, um, what we're going to do is we're just going to continue to utilize these. All right, now what I want you to do is I want you to try 4, 5, and 6 now. All right, so 4, 5, and 6, they're listed here. Pause the video and see if you get the same answers as me. All right, so number 4. All right, so here you go. You can see the answers to 4, 5, and 6 here. Again, change them to the reciprocals, type it into our calculator, and we're good to go. Now, 7 and 8, how do we do this? Now, when we were doing 1 through 6, when you do cosine of 23 and the secant of 12, what you're doing is you basically are finding the ratio of the sides. You're finding what the opposite over the hypotenuse or the hypotenuse of the adjacent, what they would be. Now, if we look at number 7, all right, this is having you find one part of your ratio, all right? So here, okay, remember that these are that these are things that we can use, cross multiplying to find, and that's what we're going to do. So there's 2 ways to do this. So I'm going to show you 2 ways to do it. First is we can just straight up cross multiply. So we can go x times 1 is x equals 7 times the secant of 25. So it's 7 times the secant of 25. Now, normally, you'd be like, we're done. We can go ahead and do that. Well, here's the deal. Secant of 25 is not in our calculator. So this is really x equals 7 times 1 over the cosine of 25. And that's what you would have to put in your calculator. So you're going to have to take your calculator out right here. 7 times 1 divided by the cosine of 25, and bam, that's what we're going to get. All right, so you're going to get about all right, about, what is it, 7.72. All right, that's what x would be in this ratio of stuff. Now, I said there's two ways to do it. So here's the second way, all right? So let me erase this so we can see it. Now, here's the deal. Secant is what we call a reciprocal function. So that's why we put it 1 over. So what we could do, all right, what we could do here is we can say, all right, I can change secant right here. I could just change this into looking like this. 1 over the cosine of 25 is equal to x over 7. So you could do it this way, and you just cross multiply here. So when we do this, all right, we're going to get 7 equals x times the cosine of 25, divide by the cosine of 25, divide by the cosine of 25. And you might be like, well, that's not the same thing. Well, it is. 7 over the cosine of 25 is the same as 7 times 1 over the cosine of 25. So if you typed in your calculator, 7 divided by, not 2, cosine 25, bam, look at that, we get our same answer. All right, so I want you to pause, see if you can try number 8, excuse me, and see if you can find the value of y. All right, so what I'm going to do is I'm going to change cotangent 37 to 1 over tangent. That to me is a lot easier. Tangent 37 is equal to 15 over y. Cross multiply, then I'm going to get y equals 15 tan 37, which is going to come out to, ready? Let's calculate this sucker up. 15 tangent 37, and you're going to get about 11.30. All right? And again, remember all what we're doing here, all right, is we're finding side lengths. We're finding the side length within the ratio in 7 of secant and in the ratio of cotangent. And again, it's just practicing our reciprocals and stuff like that. So here's the fun part. Now what we're going to do is we're going to go back and do some angle of elevation, angle of depression style problems, all right? And we're going to go through a bunch of them, all right? They're a little more obscure. So again, I would encourage you, if you're not understanding what's going on, pause, replay, slow it down, make sure that you're asking your partners in your groups, hey, do you understand this? Do you see what he's doing here? And see if you guys can figure it out together, all right? But hopefully I'm going to be able to explain it enough on this video that you'll get it, all right? So here's number 9, ready? A sonar operator on an anchored cruiser detects a pod of dolphins feeding at a depth of 255 meters directly below. If the cruiser travels 450 meters west and the dolphins remain in the same spot to feed, what is the angle of depression from the cruiser to the pod? What is the distance between the cruiser and the pod? Wow. Okay, so we're looking for two things here. We're looking for an angle, and we're looking for a distance between the cruiser and the pod. So let's start. Let's figure this sucker out, all right? So first thing, we have a cruiser, all right? So I don't know, like this. Maybe this is a cruiser. This looks like garbage, but whatever. All right, there's your submarine cruiser, whatever you want to think about. All right, could be a ship. All right, and then there's a dolphin down below. Now you're going to be like, that's a fish, Mr. Plowman. Yep, look at that, smiles fish. All right, now, right now it says that the depth directly below, all right, this ship is 225 meters, all right, meters. Now it says that this ship, all right, this ship travels 450 meters west, which is this direction, all right? So our new ship is here, all right? There's our ship with the little portal, whatever it is, all right? And now it says, what is the angle of depression? So look at this. We get our little angle here. This is our angle of depression. So, all right, I can label one more thing because we went 250 meters west. That's this way, 250 meters west. That's basically our horizontal, all right? So what we're going to do is we're going to figure out what theta is. So in order to find theta, using theta as our side that we're going to label, this is our opposite. Our hypotenuse is the diagonal. I don't really need that right now, but I got my adjacent, ADJ, all right? So what I'm going to do to find theta is I'm going to realize, okay, I need to write SOHCAHTOA, SOHCAHTOA, and I realize, adjacent opposite, that's tangent. So I'm going to do the tangent of theta is equal to opposite, that's 225, over the adjacent 450. All right, now, here's the deal. We got to find theta. So to find theta, all right, this is what we got to practice again today. Theta is found by doing tangent inverse. Tangent inverse of both sides is going to unlock our theta, because it's going to cancel out that theta, saying theta is equal to tangent inverse of 225 over 450. And that now is what our calculator is going to be doing its work for. All right, so we're going to go second tangent, 225 divided by 450, hit enter. and theta, our angle of depression, is about 26.57 degrees. So that is our angle of depression from the new location of the pod. All right, this is the new location to the dolphins, my wonderful dolphin picture. All right, that's the angle of depression to there. Now, the next thing it says, what is the distance between the cruiser and the pod? So here's the cruiser, here's the pod. This is what we're looking for. So what we can do is one of two things. To find this, we could do Pythagorean theorem, and that's probably what I would do, all right, to find this. Or you could do trig, all right? Now, I'm not a big fan of trig right now because we're using a, if you have to use this angle, right, you're using a rounded version. So it's not going to be as super duper accurate, but it's still going to be pretty darn close. But for me, I'm just going to do this, all right? Since I'm looking for the hypotenuse, it's going to be 450 squared, all right, plus 225 squared equals x squared, all right? Leg squared plus leg squared equals hypotenuse squared. And watch what I'm going to do here, all right? I'm going to just put this all in my calculator. I'm going to go 450 squared plus 225. Is it 225? Oh, sorry. Not 225, 255. Let's make sure we edit this. 255 squared, all right, equals, up. I messed something up with the degree. I'll come back to that one in a second. Equals this. Ready? 267,525 equals x squared. Now, let's pause, all right? And I messed something up here, all right? Some of you might be yelling at the screen and be like, oh, now he finally adjusted. This shouldn't be 225, it should be 255. So we actually have to do tangent inverse differently. So ready? We're going to do tangent inverse. Let's actually get the correct calculation. Tangent inverse of 255 divided by 450, and this is 29.53, 29.53. There we go. So some of you are like, finally, knucklehead fixed his mistake. Now back to this one right here. So we did 450 squared plus 225 squared, or 255 squared equals x squared. So now our last step that we have to do to find our diagonal distance is we got to square root, all right, which is second x squared, 267,525, and you're going to get about, x will be about 517.23. I think we're talking about meters away. So that is your diagonal distance of the new pod to the ship, where their location is, okay? So again, some of you are like, all right, this actually isn't too bad. Good, all right? Again, Pythagorean theorem, you're always welcome to use that, especially if you're given two sides. So let's see what's going on here with number 10, all right? Number 10 says two office buildings are 36 meters apart. The height of the taller building is 196 meters. The angle of depression from the top of the taller building to the top of the shorter building is 19 degrees. What is the height of the shorter building? Refer to the diagram below. All right, so here's the deal. We have the distance of the taller building is 196. We want the shorter building's height. That's x. That's what we want. We want this, shorter building's height. Now, we know that the distance between the bases of the buildings is 36 meters apart, which we're going to bring up here. All right, this will be 36, because remember, we always want to bring our values into our right triangle. All right, and actually we might move it one further, and you'll see why in a second. All right, now it says the angle of depression from the top to the bottom. So top to bottom, which means we need this as our triangle. So this angle of depression is 19 degrees, because the angle of depression means from the horizontal down, which means we're going to take this 36 and we're going to scoot this sucker up here. 36 is going to be there in our right triangle, because that's how you draw angle of depression problems. Your angle is up at the top. All right. Now, here comes the fun thing. All right. We want to know what the height of the shorter building is from here down. How are we going to do that? And some of you might be saying, well, maybe we use this 196. Well, we will. Watch what we're going to do. If we knew, let's say, for instance, we knew that this distance was 100, all right? What would be the shorter building's height? And everyone's screaming at home, it's 96. And I would say, well, how do you know that? And you're like, well, if we know the top part is 100, this is 100 over here, we would just go 100, take away from 196, 196 minus 100, and that's how you get this shorter building distance, all right, of 96. Well, okay, it's not 100. But we're going to do the same thing. What we're going to do is we're going to say, all right, let's call the distance of the top to the shorter building, let's call this y. And let's see if we can figure out how different the height is from the taller to shorter, and then we'll subtract that from 196. So that's what we're going to do here. So from 19 degrees, we have our opposite. All right. Our hypotenuse is not given, so we have our adjacent. And I got a little bit of SOHCAHTOA here. Again, I would encourage you to just write this at the top or bottom of one of your papers so you can use it again. And notice we are going to use tangent because we have opposite and adjacent. So we're going to say, all right, well, the tangent of 19 degrees equals opposite, that's y, over the adjacent 36. All right. Now, some of you might be saying, why did he use y? Well, again, x was used, all right? X is used down here. I call it x. You could call it x. It doesn't matter, all right? But y refers to the distance between taller and shorter, and then x is going to be whatever the shorter building's height is going to be, all right? So to solve this, we'll cross multiply, so we'll get y equals tangent of 19 times 36 is 36 times the tangent of 19, all right? And now we just type this into our calculator. 36 tangent of 19, and bam, you're going to get y is about 12.39, so it's 12.40. All right, now ready? Let's get rid of that. That means y, this distance is 12.40. Same thing over here, 12.40. Well, if that's that height, what's the distance of the shorter building? Well, what we're going to do is we're going to take 196, all right, 196, and subtract out the 12.40. That's the distance from taller to shorter. And this is what our entire distance of our short building will be. So 196 minus 12.4, and you get 183.6 feet. That is the distance of the shorter building. And that's how you have to do it. So again, we do trig to figure out this missing height, subtract it from the big building, and that's how we figure out what the shorter building is. All right, not too bad. All right, let's flip the page. All right, I believe we have 2 more questions left. Let's see what we can do here. All right, it says a salvage ship sonar locates a wreckage at a 12-degree angle of depression east of the ship. So ready? I'm going to draw my angle of depression. Bam, here we go. All right, here we go. 12 degrees east of the ship. So that's what angle of depression is going to look like. A diver attached to a thick cord is lowered 125 meters to the ocean floor. So if he's lowered downward, all right, that means that we're going to put this 45 meters over here. That's going to be your horizontal. All right. Now the question says, how far east does the diver have to swim to reach the wreckage? So east-west, when we do east-west, that's left-right. All right. So this is going to be X. So what we're going to do is we're going to do trig to figure out what that would be. Okay. So we're going to figure out how far east does the diver have to swim. So we're going to do, ready? Across from here is opposite, and X is your adjacent. So like always, we are doing tangent, all right? And I don't mean to say like always, but we have been doing tangent a lot. So the tangent of 12 equals 45 over X. We'll cross multiply. So we're going to get 45 equals X times the tangent of 12. Divide by the tangent of 12. Divide by the tangent of 12. And you're going to get X is about, all right, ready? What is it? 45 divided by the tangent of 12. Bam. You're going to get 211.71. What are we in? Feet? What's our unit? Meters. All right. So that is your how far east-west your diver would have to swim. All right. Now, that's what that is. Now, the second question says, what's the length of the rope once the diver has reached the wreckage? So if your diver starts here, goes down, and then goes east, technically the rope, ready? What will happen is the rope actually starts to go this way. So this problem, this second part, is actually looking for your hypotenuse. So this is what we'll call y. So we're going to do our hypotenuse now. Ready? So we're going to go, we'll do Pythagorean theorem. 211.7 squared, right, plus 45 squared equals y squared. So we're going to put this again in our calculator. 211.7 squared plus 45 squared. All right. So there you go. You're going to get 46,841.89 equals y squared. Then we square root this. So second x squared. Now watch this cool trick. Instead of typing this all in, I'm going to hit second answer, the negative sign. And that's just one way to save us some time. So our y value is going to be 216.9 0.43 meters. And that is the length of the rope that your diver is going to have. All right. You see that? All right. Now, the next question says, a sudden wind moves the boat 10 meters west of its starting location. All right. What's the angle of elevation from the wreckage, and how long is the rope extended now? So, all right, here's the wreckage. I'll put this with a little star. And then now the boat's going to move west 10 more meters. All right. So what we're going to have is we're going to have a new triangle. Ready? So here's our wreckage. It's still 45 meters deep. And our width, all right, again, we found this X is 211.71. And now we move 10 more further away. So it's going to be 221.71 because we had to add these two values together for our new problem. So what we want to find is our new angle of depression. So ready? To get that new angle of depression, we're going to do some trig here. We have our opposite. We have our adjacent. So we're going to do tangent of theta is equal to 45 over 221.71. And to find our angle, we do tangent inverse. All right? So we'll get theta equals the tangent inverse. Ready? Well, let's calculate this up. Second tangent, 45 divided by 221.71. And you're going to get about an 11.47 degree angle of depression. All right? So that's how you do that one. And really the trick here is understanding that moving west, all right, means you're moving this way. So we had to add that 10 extra meters from the original problem. All right. So this is what I want you to do. I want you to try, all right. I want you to try your homework now. Okay. We'll do number 12 together. All right. So your homework is the next page. All right. Worksheet 9. You'll see this 1, 2, 3, 4, 5. And then the next page 6, 7, 8, 9, 10. And notice the answers are at the bottom. So that's what I'd like you to work on, right? And again, please check Google Classroom for the filled in answer key. I will have a few problems filled in, right? And then we will work on it on the next day when I get back, all right? Have a great day. Be good for the sub. Peace.